All right, I think we are ready to go. Good evening, everyone. My name is Sarah Fenton, and I'm the health reporter here at St. Louis Public Radio. Welcome, and thank you for joining us at our 2021 virtual Mini J School at St. Louis Public Radio. We're a member-supported station at St. Louis, or University of Missouri St. Louis, an institution that transforms lives through education. We want to thank our members for supporting us. For our more than 26,000 donors, many of you among them, contributed over $6 million last year, allowing us to bring you award-winning news, podcasts, and events like our Mini J School. Tonight, we're excited to be talking about weather reporting and climate change. Television news managers know that in many markets, the weather is what a lot of people watch for. Mike Roberts, formerly of 5 on Your Side, otherwise known as KSDK, will share insights about the decision-making process of making the forecast, sharing that information with viewers, and helping them inform the news department's decision-making process for the coverage of weather-related events. We'll also explore the role climate change is having on television weather and news decision-making. Joining Mike will be 5 on Your Side Chief Meteorologist Scott Connell and Dr. Jennifer Francis from the Woodwell Climate Research Center. Mike Roberts is the Business Development Manager for the new program from Ascension Living called Live at Home, which is designed to help older adults who would rather stay in their homes than go into a senior community. Prior to joining Ascension, Mike was the Manager of Public Relations and Communications at the Visiting Nurse Association of Greater St. Louis, a role he took following a 37-year career in television as a meteorologist. From 1996 to 2016, you could always find Mike on KSDK TV5, where he won 4 Emmys. He still does a daily forecast and the Saint of the Day for the Covenant Catholic Radio Network. So he's a radio person, and we like him for that too. Mike was also an adjunct faculty member at the Department of Earth and Atmospheric Sciences at St. Louis University from 2004 to 2016, where he taught broadcast meteorology. In addition, he's a member of the board of directors at Voice, which advocates for older adults living in senior communities, as well as informational resources for seniors and their families. Mike is going to introduce our other guests in more detail. So take it away, Mike.
Thank you so much, Sarah, for those kind words. And thank you to you, Sarah, to Leslie Davis, to everybody at KWMU. What a great team you are. What a great radio station. I'm among your biggest fans, and I know you have a lot of big fans. And I hope, especially in this moment in time, any fans that are listening will send a little donation your way. I was in the inaugural class for the St. Louis Public Radio Mini J School back in May of 2019. And on that night, we talked about the role historically of weather in a television newscast, where weather is now. And at the very end of the evening, we talked a little bit about climate change. And I remember saying on that night, you know, if you don't feel like you're hearing enough about climate change in a weathercast, in a newscast, locally, nationally, anywhere, don't worry, because we're going to have more severe weather, I think. And when severe weather happens, it becomes a news story. And so Mother Nature will just sit down at the table with us and bring the topic right to us. But we don't have to do that tonight. Tonight, we're going to talk about making a forecast. Those thoughts that go along with not just making, but then presenting the forecast, and then the decisions involved with phrasing severe weather within a weathercast, and then where that crosses over and becomes not just a weather story, but a news story. And then what about ongoing severe weather coverage? And as we look forward into the future, we are going to be talking about the role of climate change in kind of forcing us to discuss this issue. What is the severe weather potential for our future? So joining us tonight is Dr. Jennifer Francis. She is a senior scientist at the Woodwell Climate Research Center, a pioneer in the use of satellite data to understand Arctic changes. Dr. Francis is going to be explaining to us how rapid Arctic warming can generate weather extremes even in our portion of the planet. Scott Connell, the chief meteorologist at 5 on Your Side, been around for a long time. We all know Scotty, we all love him, and an Emmy Award winner himself. He's been at Channel 5 at 5 on Your Side for 30 years. His first job was when he was 14 years old. So thank you both for joining us. Scott, I'm going to start with you. And I guess my first question has already been begged. How, Scott Connell, do you end up working at a television station when you're not old enough to drive to a television station?
Well, I basically, I knew I wanted to do weather, and we had a new TV station coming in the small town that I was in, and I told my dad I wanted to do it, and I put on, he said, well, you need to go talk to the general manager. So I didn't know who that was. I didn't know what a general manager was. And he took me down there and dropped me off. You know, I wore my one tie, one dress shirt, gray pants, navy blazer, and went in and I want to do weather on the weekends. And they of course chuckled, but they sent me over to the news director, and who I didn't know what a news director was, who handed me a resume and said, have you ever heard of a resume? No, I don't know what that is, but he pulled one off his stack, handed it to me and said, go home and make one and bring it back. We'll see what we can do. And so I did, you know, school safety patrol, church choir, that sort of thing. That was on my resume. But they did give me a job researching the record highs and lows. And back then you had to use microfiche because, you know, we didn't have computers back then the way we have now. And so now something that would take, you know, 10 seconds, well, maybe a minute or two to generate, you know, back then it took me a couple of hours every day writing down every high and low temperature that had ever been observed in my little town in Maryland and coming up with the highest and the lowest.
Well, Scott Connell, you're 10 years younger than me, so that puts you in your mid-30s because I'm in my mid-40s.
Right.
But so actually what I was going to say is we start our careers plus or minus right around 1980. So we're leaving the world of magnets on magnets to explain the weather for 3 or 4 minutes at a time, and we're going into the computer world in every way, both in the way we present the weather and in the way we forecast it. So how was that journey for you? When was your first computer showing up, and then how did that change from back in the day?
Well, and I think, Mike, you can look at this from an example of just the severe weather operations that we undergo now when we have all of our computers and everything. And the amount of information that's not only available to us as meteorologists, but it's available to anybody because it's on the web, the Storm Prediction Center. You can go to the mesoanalysis page and you can get this whole array of severe weather indices for whatever you want, tornadoes, hail, you know, how a supercell index. And when I think back, Mike, I know you're probably in the same boat. I think we had maybe 3 or 4 indices back in the day, and our computers were running on tape, spinning in the university, and that was considered advanced, you know. And along came the Commodore 64, and then we started getting PCs and things advanced. Now everything is literally at our fingertips, and there's almost so much information that it becomes hard to digest all of it and to absorb it. And then you really have to rely on a lot of what you've learned in your past experiences when trying to forecast and make a, you know, even in a short term kind of scenario, make a determination of what's going on.
When we started, there was the first computer model for forecasting that came out, the limited fine mesh, and there were other people who had other acronyms that they used, which we won't use right now. But now we've evolved, and I remember it being, you were insane if you swallowed that stuff whole and spit it back out. But now it's almost the other way, isn't it? Where the model guidance is so good. You're insane if you try to outthink it. So let's go there, Scott. What is your forecast process right now? How do you make a forecast?
Well, you know, and the National Weather Service, in fact, they just updated the America model. You often hear us talk about the America model and the European model. The models, and the America model just got upgraded, I guess, literally today. They're still working out some kinks with some of our providers, but it's updated to be better resolution. And, you know, we have bigger computers, we have more ability to run the equations, because when you think of it, you know, the Earth being a sphere or very close to, a sphere, and the atmosphere being fluid and moving, you have literally thousands and thousands of computations that have to be calculated over and over again. And so you really need these computers that are just outstanding and unbelievable that can do that. And so we've come so far with that now, and we run so many versions of these models that have slightly different physics in them. And I say we, it's not me, it's the government, it's the National Weather Service, it's the European Union. It's people far superior in knowledge than I am. But we get all of those outputs. And the big trend now is for ensemble. And the National Weather Service has actually come up with their national blend of models, which takes not only the global models, but also takes all of the smaller, higher resolution, shorter range models and brings all of that information in, aggregates it, weights it based on what computer model may be performing better than another, if one's doing better than another, and aggregates it and then spews it back out to us and gives us a statistical forecast, which is a great starting point. And, back in the day, I don't think, Mike, you and I could even imagine anything that we would have a starting point for making a forecast that's as detailed as what it is now.
It would take 12 hours to run those models, but as the computers got faster, the resolution got tighter, and the decision-making just transformed. Now, Scott, I want to ask you about severe weather and your thought process there, and then when you take those thoughts into the newsroom, how do you take them? And but before that, now this is research that I'm going to give to you that's a couple of years old now, and 2 years today is not the same as it was in 2019 because there's the I don't think we're in the post-COVID era yet, but there certainly is a pre-COVID era. So this is from the Pew Research Center, Scott. It's from 2018. Said that after sampling 35,000 people, 70% of those viewers said that the most important thing in making decisions about their daily life revolves around the weather. 70% said weather is the most important thing, 44% crime, 41% traffic, 19% schools, 10% sports. That's 2018. That is pre-COVID. Is that still relatively close, do you think?
I would think it's relatively close because in the scheme of things, the only thing that affects each and every one of us in some way, shape, or form every day is the weather. And so, it is a driving factor. Now, people want their forecast. We all now have our phones, and you have apps out the yin yang on the phone. And, people can call and they want to know, why am I seeing a snowflake 4 days from now or 5 days from now? And Mikey, my forecast philosophy going out in the extended, we don't put snowflakes, we don't advertise severe weather when we're getting into the farther away parts of the forecast without having a pretty good basis. And here at St. Louis University, we have the SIPS program, the Cooperative Institute of Precipitation over here, where we do the analogs. They run the analogs, and we can say from a similar model run, this model run looks like these previous years. Here's where the most likely area of severe weather would be. Here's what the average rainfall out of those selected runs that come up with analogs, which, that's not a computer model. It's based on a computer model, but it's actually correlating that with history. And so that's also a good starting point. So when you're talking about the extended forecast, we really, and this is something, because I don't like to freak people out. And I think there's too much of that goes on in the world today where we go about our business. If we get everybody all excited, we'll get the desired result. And I don't know that that's really the right thing. That, the result you get usually isn't what you were anticipating. And so there's enough anxiety from people when it comes to bad weather that we want to put facts out there, or what we believe we know, that yes, here's a concern, here's something you should be thinking about, and be aware that this is a possibility, but without sounding the alarm. And we do like to sound the alarm when all the signs are there, and when it's pretty locked down that there's definitely something going to happen. Something's going to be very impactful, especially if it involves, a life or death situation potentially. Then you're sounding the alarm. You're going to let people know, but you're still not going to do it in a panicked manner, because if you're flipping out, then you're not going to get the response you need out of folks, and you need people to think and take action and be prepared and know what they're going to do. And I think, Mike, as we go farther down and get to talk to Dr. Francis, I'm really interested and excited, Dr. Francis, to hear more about what research you have had, in your experiences as well, because, I don't have enough, I'm not a climatologist. I don't have enough of a background to, make the big claims. And I think, Mikey, you've said it many, many times, it is more of a story than we're able as weathercasters to present because of our time constraint.
So when you've reached the point where you are very sure we're going to have at least strong weather, severe weather, maybe even tornadic weather, but how do you communicate that to the newsroom? And to some extent, you're attempting to both control the message that you're sending, but also the message that they're sending. So what's the thought process there?
Well, and I think that's one of the things, because the newsroom, they like headlines. The news department, the news business likes headlines, and they like something that's going to get attention, going to draw viewers. And so you walk a very fine line with how far to play things up. I try really hard to go talk to the producers. Obviously, we're in COVID right now. There's very few here. Most of our newscasts are produced by people that aren't in the building. They're working from home. So we have a very limited number of people here. But in the old days, we would go out to the meetings and when we would have our assignment meetings and editorial meetings, weather was a presence. So weather is a presence on the Zoom meetings in the afternoon and in the morning. And we kind of give them a rundown of what we want our message to be. And we're also in communication with the National Weather Service. And I think, we have our Weather Service chat, the National Weather Service chat. So we're able to talk back and forth with the forecasters. Last week, because we've had chat actually go down several times during big weather events, we tried something, they tried something last week where we were in on their Google chat as a backup in case, the official chat goes down. We at least have a backup so that we can all still communicate with each other. And so that worked out really well.
Now, Scott, take me to ongoing coverage. We reach a point now, it's been a while since I've been at Channel 5.
Mm-hmm.
Remember, the vision was at that point when I was there, and for many years before that, you have a tornado warning, you go on immediately when there's a tornado warning. Is it still the case that you stay on, what is the case now, Scott? I know you interrupt when there's a tornado warning, but how do you know how long to stay on, and who makes that decision?
Well, first of all, it in general, if it's a tornado warning, we're going to stay on. But if it's one of the tornado warnings where it's a brief spin up type scenario, not a supercell thunderstorm, that's something that's going to be very quick, very hard to detect. And by the time you see it, it's already bent down and back up. There's a good chance, if it's not impacting the immediate metro area, that we may relegate back to programming briefly and then slip back in for another update, depending on how things are going. But if it's anything in the metro area, it will be nonstop coverage. That's for sure. And it also, it goes back to, it depends on, there's so many things where it just goes into the it depends category. And unfortunately, we plan to be there and plan to be on almost all the time for a tornado warning. But when we have some of these storms that clearly are weakening, the Weather Service, once they've issued the warning, they're not going to cancel it right away. They're going to leave it going for a little bit just to make sure it's going to die down. Whereas if we can see it dying down, then we will work from there and go along and kind of try to figure it out as to what our best course of action would be, Mikey. So most of the time you're going to see us. I always say to people, the worse it is, the more you will see us. Mikey, it looks like you're on mute. We might have Mike. We might have lost Mike. We might have his iPhone there. Well, Dr. Francis, so since Mikey has left us, at least for a little bit, you've kind of got the gist of what I do as a meteorologist, and I'm in the ongoing, it's happening now. And when we look at climate is such a much longer, we're talking about the sum of weather over many, many years that forms averages and trends. And, I used to, when climate change, when it was first talked about, and it was an up and coming issue, we really did not talk much about it at all in college, honestly. But when it was first talked about, I thought, well, we have trouble with our computer models just getting into tomorrow. How in the world are we going to figure out what's going to happen so far down the road? And, I've learned that there's quite a bit of difference between what we would use as computer models and what you all would use in your research and climate models.
Yes, that's absolutely true. It's a completely different kind of model that is used to simulate how the climate system works, both looking backward in time, making sure that the models can simulate how the actual climate system behaved over the last several decades. And then, of course, we want to know what's going to happen in the future. So if we have some confidence in the model's ability to simulate what happened in the past, then when we tell these models, oh, by the way, we're going to double the amount of carbon dioxide in the atmosphere, and we're going to cut down a lot of forest in the tropics. How does that affect the climate system? And, we can look at different scenarios for the future and ask the models to show us what does that mean for storm frequency, for changes in drought, changes in heat waves, changes in cold spells. Those are the kinds of questions that really matter to people. They really matter to decision makers in communities and states at the federal level, because everybody's trying to get ready for, we've already had a lot of change, but we know there's more change coming. And we hope to be able to limit how much change that will be in the future. But of course, that's not an easy thing to tackle. But I started out wanting to be you. I got my bachelor's degree in meteorology, thinking I was going to be a forecaster. And I happened to do a senior project with a researcher at NASA. And I just got the research bug. So I decided to pivot there and go more into the research side of things. And at the time, as you say, when I went to school too, there really wasn't much talk about climate change. I mean, there was climatology classes, which, as you said, are just, averages over long periods of time that tell you, oh, St. Louis is wetter than San Francisco. But there were no courses that were talking yet about climate change. And I was very interested in the Arctic when I went into graduate school. I wanted to just study how it works. And while I was at graduate school was when we started to see the huge changes begin in the Arctic, in particular, how the ice was melting. Everybody kind of expected it to happen because we knew the atmosphere was going to warm as we continually added more carbon dioxide and other greenhouse gases to the atmosphere. But to start to see it before your very eyes and to be able to measure it with some of the newer satellite data that we would be able to get our hands on at that time, it was quite a time to be getting into the field of climate change. So,
well, can you guys hear me?
Off and on.
You froze again,
Everybody
Mike.
hear me? Okay, sorry about that, you guys. And Scott Connell's bailed me out before, and there he does it again. So thanks, Scott. Dr. Francis, one of the things that I was hoping you would explain is how is it that a rapidly warming Arctic impacts our latitudes, the temperate latitudes?
Well, there's quite a few ways, actually. Some of the very most basic ways are that because, as I was talking about, how we're losing The sea ice, the ice that floats on the Arctic Ocean, it's only half as big in the summer now as it was only 40 years ago. I mean, it's just this amazingly rapid, huge change in the climate system. And we're losing the snow cover in the spring. And that combination of losing the ice, which is very bright and white, and the snow means that we're losing this very reflective mirror at the top of the world. And so a lot more of the sun's energy, instead of being reflected back to space by this mirror, is instead getting absorbed into the climate system. And so just by losing that ice and snow, we're actually making global warming somewhere between 25 and 40% stronger than it would be otherwise. So that's just a really basic way that we know the Arctic is affecting everyone, because it's increasing global warming. And of course, there's some other ways too that I know you want me to get to.
Well, so it's a feedback mechanism. The warmer it gets, the warmer it gets. But take us to the jet stream then, because my understanding is that there's a connection between what you just described and a slower moving, more amplified jet stream pattern. Is that really the case? And if it is, what does that change in amplitude mean?
Right. So the idea here is that the Arctic is warming about 3 times faster than the globe as a whole. And we know that the reason the jet stream is there, and the jet stream, by the way, is this river of fast moving winds that encircles the northern hemisphere. There's one in the southern hemisphere too. And it's up about 7-8 miles in the atmosphere, upward jets fly. And that jet stream is what creates all the weather that you guys talk about on TV, the high pressures and the low pressures. The jet stream is really behind all that. So anything that messes with the jet stream is going to mess with your weather forecast. So the idea is that the reason the jet stream is there in the first place is because the Arctic is really cold and areas south of there are much warmer. That difference in temperature between those two regions of the globe sets up the forces that create the jet stream. So when the Arctic is really cold and the areas to the south are very warm, we get a very strong jet stream. In the wintertime, for example, when the Arctic is super cold, that's when we get our strongest jet stream. That's when we get our strongest storms. And then in the summer, the Arctic warms up and the jet stream gets much weaker. So follow that logic. As we warm the Arctic much faster than we warm everywhere else, we're making that temperature difference between those two places smaller. So there's less force to drive the winds of the jet stream from the west to east direction. And we know that when we have a weak jet stream, it tends to be more easily deflected from its mostly west to east path. I mean, it always has the north-south undulations in it, as you guys observe every day. But when the jet stream gets weak, it's more easily deflected from that west to east path by a mountain range, for example, or even differences in temperature out in the Pacific Ocean. And so we tend to see these bigger north-south swings in the path of the jet stream. And the reason that's important is because when those north-south swings or waves in the jet stream do get large, the whole pattern tends to be locked in place and they tend to move much more slowly. And those waves are what create those highs and lows, as I described. So if they are not moving, then your weather is going to feel like it gets stuck. And it could be in a cold pattern, or it could be a dry, sunny pattern, or it could be a stormy pattern. So it really depends on where you're located relative to these waves in the jet stream.
So is it the case then that those predictions, we're going to see more extremes, more and heavier downpours, more and prolonged droughts, and whatever kind of extreme you have is going to take longer to last? Is that true? And can we go so far as to connect this recent Arctic outbreak to just this kind of change in the jet stream pattern?
Well, some of those extremes that you just described are very clearly linked to climate change. Like, for example, the frequency of heavy precipitation events. That's something that we've measured very clearly. There's no doubt about it. The most important reason behind that, though, is the fact that because we're warming the oceans and we're warming the atmosphere, there's a lot more water vapor in the air now than there used to be. There's about 4% more, roughly, on average. And so that water vapor then can be gobbled up by a storm, and so any storm that's forming now is forming in a completely different atmosphere from what it used to be. It's got more water vapor to work with. It dumps heavier rainfall or snowfall, and that extra water vapor also provides energy to storms, and so those storms tend to be stronger. But getting back to the jet stream and the changes in the sort of shape and the configuration of the jet stream, we know that when it gets into one of these very wavy patterns, we tend to see a lot of unusual weather happening. And of course, that's exactly what happened in February when we had that extreme cold spell in the middle of the United States and all of North America for that region, for that matter. And what made that, I mean, we always have cold spells in the winter, that's normal. And they're always associated with a big dip in the jet stream that allows that Arctic air to plunge far south. But what made this one so unusual was because it penetrated way far south than normal, all the way down to the border with Mexico, and places that just aren't used to having temperatures around 0 degrees Fahrenheit and snow and ice were just, it was a terrible situation. They're just not used to it. And those big dips in the jet stream, we can't blame that on the Arctic per se, but what we can say are those kinds of patterns with those big wavy jet streams are more likely to happen in the future. So
well, could I flip the question on you then? Could I ask you if it's the case that any weather system could be unaffected by climate change? Aren't they all at this point in time impacted in one form or another?
Yeah, Scott's nodding his head too. It's a different atmosphere now. There's more heat, the oceans are warmer, there's more water vapor available, the north-south temperature differences has changed. We've seen very different patterns in ocean sea surface temperatures. We've got this cold blob sitting south of Greenland right now that we think is related to Arctic warming and extra fresh water coming off of the Greenland ice sheet and the Arctic Ocean. There's so many changes that have happened as a result of climate change that absolutely any weather pattern, any weather system that happens now is happening in a different backdrop. And so the question is, of course, with any individual storm or any individual event, how much of that was due to climate change. And we're getting better at being able to simulate those kinds of things with those models that we were talking about before, where we can run a weather model basically in a background situation that corresponded to what it was like back in the 1970s. And then we can jack up the heat, jack up the moisture, change the ocean temperature patterns and see how that same storm would have developed. So some of these new techniques are really coming to the fore now.
Well, Dr. Francis, one of the things that, as I did some research on you, I think they call it stalking, but I hope not, is that you have been pulled outside of your comfort zone at times by this very issue. You found yourself sitting in front of legislators in Washington. And I think anybody who ever knew me for 10 seconds knows I'm not above puns, but do you think there's been something of a thaw in the open discussion about climate change to the point where we're actually ready to go forward with this?
I absolutely believe that. I mean, there are polls of the public, and we've seen a steady increase in the fraction of especially Americans who think that climate change is a severe a bad problem. It's not just a concern, but it's become one of the biggest problems that we have to face. And I credit actually the TV meteorologist hugely in helping with that, because you are in many cases the only scientist that people ever know and that ever listen to and they trust. And so really, I think you have a huge role to play here in whenever there is some event or some weather pattern that you can draw in something about climate change and start to help people understand, this is the kind of situation that the research tells us is probably going to be happening more often in the future. We're already seeing it happen more often. And
Well,
so
I didn't mean to interrupt you, Doctor. I want to ask Scott a question here, because Scotty, our own journal, the American Meteorological Society journal, back in April, just 2 years ago, had released some research, and this is what it said, Scott. 72% of the people that they talk to think that climate change will harm people, but in the future. 71% other species, 62% those in other countries. But Scott, only 42% of those that they interviewed in 2019 anyway, thought it would impact them. So how do you, Scott, talk to an audience if it's the case that only 42% want to hear about this?
Well, and that is part of the problem. And I think, from my perspective, it seems like everything, science, and this last year is a good testament to this. Everything seems to be political, and science is apolitical. When you do science, the scientific hypothesis doesn't care which side of any aisle you're on or who you are or where you live. It's science. And we're not without our faults, and we don't know everything. And when I do school talks with kids, I say science is all based on somebody saying, well, why and how, and then trying to find the answer to that. And I think it is difficult with some people. They don't want to hear about it. They just flat out deny it. But there are also people that still believe that the earth is flat, and we know that that's not true. So, there's a certain population we will never, ever reach. And then there's a population that's, well, gosh, we didn't used to have this. And they can start listing off on the items of this. We didn't have 5 and 6 inch rainstorms before. We didn't have it get this cold, this fast, this way. It used to be different. And I think more of us, and Mike, we talked about this probably 15, 20 years ago, that in mid-America, our biggest problem was not going to be that the temperature was going to be exceptionally warm. We were going to see a lot more frequent rains and heavier rain events. And I think when you look at the flood forecast and the flood stages on the Mississippi and the Missouri rivers over the last decade, how many times have we been high, moderate, and into major flooding? Which it used to be decades before you would get another recurrence of something like that, and now it's like every other year.
Well,
So,
I'm just gonna loosely quote some research from St. Louis University that is about that old, about 15 years ago, that looked at temperatures and moisture in June, July, and August across the lower 48. And the temperature was like 7 to 8 degrees Celsius warmer than normal in the Northwest, about that in the Southwest, or more than that. But here in the middle of the country, it was only like half of a degree to 1.5 degrees above normal. But that was because we're going to have like a 30 or 40% increase in storm flow. I'm just going on the basis of memory, but basically it's not electric like some of these other conversations. So I have just one more question for you, Dr. Francis, and then Sarah, if you'll take it back, and then we can go to questions and answers. But Dr. Francis, the same question that I asked Scott, for Scott's talking to a public that may not necessarily want to hear about climate change on a daily basis. How do you talk to legislators and the folks who are going to be game changers for us, and not just for us in this moment, but for our future?
Well, the legislators are some of the decision makers that are going to decide, whether our infrastructure is sufficient to handle those floods that Scott just talked about, or the infrastructure that Texas just displayed so clearly was totally unprepared for the kind of cold and ice that that happened. And by the way, it had happened a decade before, not quite as bad, but almost as bad. And did they learn anything? No. So I think making climate change real for decision makers at all levels, whether it's a business or a small town in New England or a state or at the federal level, I think the job of me and my colleagues is to make it clearer what kinds of extremes are going to happen more often in a particular place. Because, you can't prepare for every kind of extreme to happen in your neighborhood. And you shouldn't, because some are just never going to happen. It's just not. So I think putting a finer point on some of these changes that we expect to see in the future, how often the Mississippi is going to flood to some level, how often we're going to see a 30-inch snowfall in Denver in March, whatever it is, we need to explain that this is coming down the road. We are already seeing massive climate change. We're already seeing a huge increase in extreme weather events. In fact, they've tripled since 1980, the frequency of billion-dollar weather disasters.
I was going to say, if you want to to your point, Doctor, if you want to really look into this, it doesn't take much. Just Google billion-dollar disasters in the United States. It's stunning.
Well, we set a new record last year in the United States, depending on who you hear. I mean, 22 is NOAA, 27 was another agency, but it was a record-breaking year last year, and the year before that I think was 2016. So, yeah, it's a problem, and we can't just ignore it.
And I think something else, Mikey, I'm going to jump in real fast. The insurance industry is paying attention to this now because they're the ones that are having to, foot the bill for a lot of this. And so I think when people start realizing that the cost will get passed on and, you're going to pay one way or the other somehow, that maybe we should, and I had a friend, my mentor, Greg Fischel, for many years said, and he questioned, he's one of the best scientific minds I know. He questioned the whole hypothesis of it, but then actually met with a climate scientist and went to NCAR and had a conversation. And he came back and said, okay, I've been looking at this wrong and look at all the things I've got here. But now I forgot where I was going, Mikey. This is terrible.
Greg Fischel's point was he flipped on the subject.
He flipped on the subject and he realized that he was making mistakes. He was doing what a lot of us do with the confirmation bias. I'm only going to pull what little bit that backs up my point of view out of this massive data set.
Well, when we were going to undergrad back in the 70s and into the 80s, I think one of the things we heard was that the atmosphere is so big, you can't really change it. Obviously, that is the case. And so now it's not a question of if, but when and how fast. Scott Connell, thank you so much. Dr. Francis, thank you so much. And I know you're going to hang around and we're going to get some questions from those folks kind enough to join us when I'm here, and also even when I'm somewhere lost in the cybersphere. So Sarah, do we have any questions? Does anybody have any questions they would like to ask?
We have about 15 minutes left for questions, and we have several, so short answers. But one of the things that everybody seems to be curious about, so I'm going to kind of collapse a couple questions into one, is basically how exactly do television meteorologists educate the public about climate change? Because as Dr. Francis said, they're some of the only consistent scientists that are coming into their homes daily. And so exactly how would you work that into a weathercast? Like if you have, a huge rainstorm or something, is it your job, or do you say like, oh, and this is because of climate change? Exactly how do you integrate these conversations into your job?
Well, and that I will say, And I don't think we do a particularly great job of it, because you get 2 minutes and 25, 30 seconds. And, you have to get your forecast in there, and you have to get anything that is imperative to what's going on. So I don't think we always do a very good job of trying to link things specifically with climate change. Now, we will occasionally say, when we have a series of heavier rainstorms, that this is something, with a warming environment and climate change and global warming, this is something you're going to see more of. It's going to happen. And when there are big billion-dollar disasters, it works in. But again, you cannot specifically at this point really link any specific disaster totally to climate change. We know it has an impact, but I think Dr. Francis would agree, and you mentioned it, Dr. Francis, how much of an impact, how much of the changing climate drove this system over the edge and pushed that event over the edge. And I think that's where a lot of us can anecdotally say, man, I've never seen anything like this before, or this used to never happen this often. It's happening more often. Maybe this is together as part of what's going on, the bigger picture and in the longer term. But I don't think we do a great job, to be honest, on TV. Now, we did run a story yesterday. We did our spring weather special, and we did do a story yesterday that spring starts a little sooner than normal. That also causes problems with the potential of having later frosts and then messing up your agriculture industry and your fruit business, or orchards, peach and apple orchards, and the allergy season and how that impacts and plays out too. So there's a lot of impacts where we try to tie in. We don't beat people over the head though, trying to, drive it home, because that's not going to work. But you can make a connection.
And I would say that some of this is a reporting element that may not have been invented yet. We're only going to be reporting on things a television audience wants to hear about. However, every story, I don't care if it's weather or news or sports, it has to be compelling. And if a enterprising meteorologist or reporter comes along and finds a way to connect the research from Dr. Francis to the Arctic outbreak that we just had and to somebody living in Creve Coeur, I think that's it. If a story is compelling, people will listen to it or watch it. So it's incumbent upon those folks who are on the air who feel like they not only have the green light to do this, but I know your heart, Scott Connell. It's also, you're on a mission. You're on a mission to explain. Sometimes people don't want to hear about the tornado in the middle of the Stanley Cup playoffs, but you got to tell them. And this is a version of that. What are your thoughts, Dr. Francis?
Well, I totally agree. And I think more and more TV meteorologists are embracing the really responsibility to inject some information about climate change when something unusual does happen. I like to think about it as sliding a little spinach into your cheeseburger, where you've got this extreme event happening. Everybody loves to hear about that. It's because it's exciting. It's wild. Everybody loves to talk about the weather. But then if you can just bring in this little nugget of climate information related to that extreme event and say something like, well, we've been expecting these kinds of events to happen more often. And sure enough, look, if you look at this trend here, we see that the flooding of whatever, or, the amount of rainfall, whatever it happens to be, is actually going up. Just like, we expected it to, warming climate. So there who have been given the green light by their network to spend more time talking about this and going into deeper depth. And I think that's been happening more and more, which I think is just coming down the road. And it's partly your audience, as you said. I don't think the younger generation watches TV news that much. They're really watching it on their personal devices more, and they're getting a lot of climate information that way. So it's partly who your audience is, what your producer feels like they want to hear. But at some point, this is such a big problem that's facing all of us. You got to get over that, what they want to hear, and tell them what they need to hear.
And as proof that Dr. Francis has talked to politicians, she actually used spinach and cheeseburger in the same analogy. That's impressive. But we want to stay hopeful. We want also solutions to be part of the conversation, not to put a pretty bow on something that may not necessarily deserve that in this moment, but nonetheless, it can't be doom every story. Sarah, do we have any other questions?
We do have some other questions. And this is a little bit similar to the last question, which is how much science and meteorology do you put into your forecasts, or do you talk about in your forecast? Because I know that when a lot of people think of weather, they think like, oh, it's going to be 70 degrees on Wednesday, and then overnight it's going to be this. And how do you present? Do you ever say why, or do you ever talk about the science behind it? And how would you make that accessible to viewers at home?
Well, I think we do. We do geek out every once in a while on TV. And I will show the jet stream map with the energy, with the vorticity in there, shaded in, and just describe it as energy. We don't have to go into all the details of what everything is, but just as a little visual that, hey, this is what's going to kick this off, or what's going to charge that. And I think of, the last Dr. Francis, with the slower jet stream, when we've always known cutoff flows were slow when they would get cut off from the jet stream. But my word, what we've seen in the last few years has been, it almost seems like an inordinate amount of them, but they also are moving much slower. And for us, when they get out over the west, they just keep sending gobs of moisture our way, and we get more big storms. And so when we're trying to explain that to people at home, you're trying to pull that information, not only just the forecast, but the why and the science behind it into that with the jet stream and where the extra moisture may be coming from, because sometimes you're getting it from the Pacific and the Gulf. So you're getting a double whammy with the systems that we have. So, you try to get as much in there as you can. A lot of times we'll do things on Facebook that are a little more detailed because, as you know, we're here, on a Zoom meeting. And when you have an audience interested and wants to join you, you can just go away. If they don't, it's easy. People will come and listen and enjoy that. And they like to hear about some of the finer details. And so we try to get as much as we can in about 2 minutes.
I remember the first time I used the term the mesoscale convective system on the air. This was a long time ago, and I got an email that just said mesoscale convective system, dude, WTF. And it was so long ago. I remember looking at WTF. I wonder what and I thought, hey. But the thing is, Scott, don't you think people just love weather? They can't get enough weather. I would make this point to any university that the most popular class on your campus should be Meteorology 101, because everybody loves weather. And you can make it complicated enough for folks to respect it, but you can also really let them walk away for an appreciation of the science, but also a love for the subject. So I just think when you explained a mesoscale convective system, Scott, two things happen. First of all, they kind of like that. They kind of like that you thought enough of them to explain it. And secondly, you're starting a step down the road the next time you use that term, because they'll have heard it. But again, I would also defer to Dr. Francis on this. What do you think, Doctor?
Well, I think we should educate our public. This is stuff that really matters to them. It's stuff that really affects them. It's, the young people are all about this, about climate change and finding solutions, getting back to the question about solutions. And so, there's just a much greater awareness now and concern and a drive to do something about it, And so I think there's a real hunger out there for more information. And if you can, and I think it is possible to take complicated ideas and present them in a way that it's understandable to somebody who doesn't have a degree in math or science. And And that's something I really enjoy trying to do, is to take some of these complicated connections that are happening in the climate system and try to explain why it matters to the person I'm talking to, or to all of us.
Do we have time for one more question?
I do.
We can do one more question. It's a big question. It's from our friend Catherine, who says, it seems to me people still believe scientists don't agree that climate change is happening, or maybe there is climate change, but people aren't the cause. Why? I'm under the impression that agreement in the scientific community is about 96%. How do we fix the perception that scientists don't agree about this? Big question.
That's for you, Dr. Francis.
Well, you know, point blank, just say that it's some of those statements just aren't true. I'd say just about every scientist does know that climate change is happening. It's always happened. We've always had climate change. Before humans were walking the earth, the climate has always changed for various reasons, mostly because of the orbit of the earth doesn't stay the same. The tilt of the earth doesn't stay the same. We know there are all these things that can affect the climate. And we've known for over 100 years now that when you put more of the types of gases that absorb heat that's emitted from the earth in the form of infrared radiation, getting back to your start educating the public idea, we've known for a very long time that when you put those kinds of gases, more of that into the atmosphere, it's going to trap more heat and the earth is going to get warmer. That has been known for a very, very long time. So the fact that humans have burned all these fossil fuels, have cut down so many of the forests, of course, absorb carbon dioxide. So when you cut them down, you're reducing that ability to absorb it out of the air. It's all happening exactly the way we knew it would. And so, you know, sea levels are rising as we knew they would. The oceans are getting more acidic as we knew they would, because they absorb that carbon dioxide from the atmosphere and turn it into an acid. None of that is disputed by anybody who's a real scientist.
I think that might be all the time we have. We are at 8 o'clock on the dot.
Okay.
I don't know. Oh, wait, I'm the one who wraps up, aren't I? Well, thank you all for coming to visit us at our Weather J School session. Thank you so much to all our panelists, Dr. Francis, and oh my gosh, I'm looking at my script right now. I'm sorry, everyone. Thank you to Dr. Francis. Thank you to Scott Connell. Thank you to Mike Roberts for helping moderate this discussion. Our next session is April 5th. Join us then for Ethics of Journalism with our executive editor at St. Louis Public Radio, Shula Newman, and my editor, David Cazares, along with Mark Mehmet, who helped write the NPR Ethics Handbook. They're all really cool, really interesting, really nice people. We hope you join us then. Thank you to all our guests. Thank you for coming to visit us here. Bye-bye, and we'll see you next time. Thanks, everyone.
Thanks, everybody.
Bye, thank you.
Bye.